I gotta come up with a creepy way to start these videos every time, because I figure I start the way, same time, every time, the same way. It gets kind of boring. Boring for me, boring for you. Of course, I always have glasses problems. They're so, gotta clean them. Anyway, today is the start of Unit 2. So this is 2.1. We will be graphing radical functions. Oh my God, it's so much fun. Radicals. That's so radical, man. When I do radical equations, I drink my Dunkin' Donuts coffee. Thank goodness for Dunkin' Donuts K-Cups. By the way, all of this information can be www.nkinfinity.com. This website will keep getting better and better and better and better. N stands for Newman, K stands for Krause, and we will be here for what seems like an infinity. For the next 30 minutes, you may call me Mr. Key. See, Mr. K, Mr. Key, always goes the same. Okay. So let's use our calculator to graph this. Now, I could use my calculator. I'm gonna verify using my calculator. And the first thing I'm gonna use is this calculator thing called a brain. It's a thing that keeps your ears from slamming together. Okay, first and foremost, you're not ready for negatives under the radical. That's coming in this unit. You're gonna learn that in this unit, but not yet. So we're only gonna deal with whole numbers. Excuse me. We're only going to deal with positive rational numbers, which means anything bigger than 0. Excuse me, 0 or larger. So the first thing I'm going to type into this thing is the first number I'm going to use is 0. So if I plug in 0, I get 0. Square root of 0 is 0. If I plug in a 1, square root of 1 is 1. If I plug in a 2, square root of 2 is 1.414. Can't graph that. Square root of 3 is, I don't know, bigger than 1.414. The square root of 4, though, is 2. And the next nice thing I know to take the square root is the square root of 9, and that would be 3. So, again, here is another parent function. Remember I keep talking about parent function. Here's another parent function that you are responsible for knowing what it looks like. This is the function, the square root function. It looks like this. That's what it looks like. Now, if you were to come over to your graphing calculator and go into graph mode and just do the square root of x, you'll see, boom, oops, I didn't forget, I didn't know I typed that, x. Type that, that's what it looks like, okay? And if you looked at the table, if I go to Control T, you'll see the only nice numbers are 0, 0, 1, 1. Oops, can't go negative. 0, 0, 1, 1, and then 4, 2, and then 9, 3, and obviously the next one will be 16, right? Okay, so what happens when we put a negative in front? Okay, so let's think about that. And now the only thing I'm going to add is, by the way, just to remind you, this parent function you have to have memorized. If you see something that looks like that, you got like, oh, that's the square root function. It just looks like a little bunny hole slope, you know, put skier up here. Look, Mom, I can ski. I'm skiing, Mommy. I'm going really, 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 really slow. Holy crap, holy crap, holy crap. It's a bunny hill, okay? Yes, I know what you're thinking. I was an art teacher in my former life. So anyway, what's going to happen if we put the negative in front? Well, let's say we plug in 0. The square root of 0 is 0, and it's still 0. Still 0. But what happens if I plug a 1 in? Well, the square root of 1 is 1, and then I take a negative. Oh, it's negative 1. And when I put in a 4, square root of 4 is 2, and then, negative 2. And the same thing with 9. So putting a negative in it, this should be absolutely no surprise to you at all. The negative is a reflection in the x-axis. Think about this. We talked about a absolute value function in chapter 1. This was the absolute value of x. And then as soon as it went upside down, that's the negative absolute value of x. The same thing will happen with parabolas, and the same thing will happen with almost all functions. We throw that negative in front. That is a reflection in the x-axis. Okay, you need to know that. That's something you need to know. All right. So again, this should, oh, I forgot domain and range. Let's talk about domain and range. So the domain are all of the x values. Well, the x values are going to start, the x values are going to start right here, and they're going to go forever and ever in that direction. The x values here are going to start at 0 and go forever and ever in the direct direction. And again, if we go over to our table here, Control T, taking the square root of negative, look what it says, error, right? It's an error. Can't do it. So the domain for these is bracket 0, comma, infinity, parenthesis. Bracket 0, comma, infinity. Both of them are going to go to the right. Now, what about range? Well, let me get rid of my drawing. Oh, don't look like I can get rid of my drawing. Got rid of some of it. Okay, so range. Range is going to start here at 0, and look, it's going up and up and up, and if I kept drawing, it would go up and 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 up. This one would go down and down and down and down and down and down. That just ran into my head, didn't it? Down and down. So range is a little bit different. For this one, we're going to start at 0 and continue to go up to positive infinity. And for this one over here, the range is going to start at 0, but it's going to continue to, oh, wait a second. Let's back up the crazy train. Hold on, let me show you what I was about to write, and I want you to see if that doesn't make any sense. Let's start at 0 and keep going to negative infinity. No. Remember, the small number has to go on the left, and the big number has to go on the right. So I got this backwards. That's what makes this one a little bit trickier. Is you have to start at negative infinity and go all the way up to to 0. So the lowest it's going to be is down here at negative infinity, and the highest it can be, or the highest value it will be, is 0. All right, so that's domain and range for the square root function, okay? You're going to become familiar with that. All right, now I told you back when we did the absolute value functions that we're going to start generating some transformation ideas that you have that are going to be the same whether you're dealing with an absolute value, dealing with a parabola, you're dealing with a radical, you're dealing with a cube root. It's going to be pretty much the same. If you remember correctly, all absolute value functions go through the origin until you make a transformation on it. So this is the absolute value of x. But remember, when I did absolute value of x and I put a +3 on the outside, didn't that move up? And if I made that a -3, it would move down. If you remember correctly, we did absolute value and put the x +3 inside. And remember, on the inside, it moves backwards. So this would move to the left 3. If I put an absolute value of x -3, it would move to the right 3. Well, nothing's going to change here with these. This is the nice thing about these transformations. It should be obvious what's going on. Notice we are subtracting 3 on the inside. This is a shift to the right 3 units. To the right 3 units. So normally I'd have 0, 0, and then I'd go up 1, 1, and then I'd go up 4, 2. But now everything's going to shift to the right 3 units. So now this 0, 0 is going to go over here. I go over 1 and up 1. Then I'm going to go over 4 and up 2. Now the next one I would go over is over 4 up, another over 9 up 3 from this point. But that gives me my graph right there. And while we're here, let's talk about the domain. Now the domain now is going to start right here. This is the lowest x value. That's now 3. So bracket 3 going to positive infinity. Range is not going to change because notice my range is still starting at the origin here. And notice it just keeps going up and up and up. So my range is bracket 0 to positive infinity. Now over here, we made 2 changes. We're going to move to the right 3, because remember, whatever's in there is backwards, 3. And up, 4. Remember, on the outside, it's up or down, but normal. On the inside, it's left or right, backwards. On the outside, it's up or down, normal. So that's why this point normally would be here, and I'd go up 1, and then I'd go over 4 and up 2. And I'd go over perfect squares, over 9, up 3. I would go over perfect squares. Well, now I'm going to start here. 1, 2, 3 units to the right. 1, 2, 3, 4 units up. That's this point right here. And I go over 1 and up 1. I go over 1, 2, 3, 4, and up 2. And then I'd go over 9 and up 3 from there. But now, do you have to memorize that? No, absolutely not. What you will probably end up doing is, now, should you be able to tell that this thing makes this graph without a calculator? Absolutely. Will you have to in my class? Absolutely. I will give you this function and a graph, and I'll say, hey, you've got to match those. It's just being a very quick matching. Do you understand the idea of transformation? Did you know that we're going to the right and up? But if you had a calculator, you just come over here, Control T, Doc B, go back into graphing, and then you just type in the square root of x minus 3, and then you put a plus 4 on the outside, and there it is, way off there into space. Okay? But how do I plot those points? You just go over the table, Control T. Now the first point that's going to be available is 3 because that's the first time, 3, 4. We moved over 3, up 4. So 3, 4, 4, 5. Now the next one, starting at 3, we got to go over 4 units. So the next one's going to be 7. See, now 7's the nice one. And then you got to go over 9. That's going to be 12 is the next one. That's nice. 12. There it is, 12, 7. Okay. Oh, so domain. Let me erase this. Okay, so domain, we are starting at, here's the leftmost value, and we're going forever and ever in that direction. So domain is the same as the last one, 3 to positive infinity. The range, however, is now moved up. We're starting here at 4 and going up. So bracket 4 to positive infinity. Evaluate, why am I doing this? Okay, whatever. F of 4 is equal to the square root of 4, which is equal to 2. G of 9 is equal to the negative square root of 9, which is equal to negative 3. And this is some of the work we've already done. And H of 3, simple, all I'm doing here is, can you substitute in, can you use function notation properly, plug in the 3 for where it's got to go. H of 3 is equal to the square root of 0, which is just 0. All right. So what happened when we put a number that was bigger than 1 in front? Do you remember what the absolute value is? I mean, if we had absolute value function, and I said, okay, this is f of x. F of x is equal to absolute value of x. You draw, oh yeah, that's just a normal absolute value function. But what, do you remember going through the transformations and when we put a 2 out front, what happened? Oh yeah, it got steeper. And if we put a 3 out front, it would get even steeper. But what happens when I put a half out front? Oh yeah, it got wider. It's a dilation. So anytime I put a number in front, it's either going to be a dilation of making it steeper or a dilation of making it wider. In this case, we put a 2 out front. So we're going to dilate this and we're going to make it steeper. So instead of starting at 0, you still plug in 0, you get 0. But if I go over to 1, the square root of 1 is 1. It doesn't go through here anymore. Now it goes up times 2, so it's going to go through 2. I should be doing these in a different color, green maybe. All right, so instead of going over 4, 1, 2, 3, 4, and up 2, it's now going up twice as much, times 2, 4. And instead of going over 9 and up 3, it went over twice as much, which is 9. And again, you can get these table of values from. Let's answer the questions before we tackle that one over there. So domain, 0 to infinity. Range, 0 to infinity. Okay, that's not a problem. Is it a function? Does it pass the vertical line test? Yep. Can't draw a vertical line without hitting it more than once. So yes, it passes the VLT, the vertical line test. Okay. Is it a one-to-one function? In order for it to be a one-to-one function, it has to be a function, which we just determined it is, and then it has to pass the horizontal line test. So in order for it to be a one-to-one function, it has to pass both the vertical and horizontal line test. So is it a one-to-one function? Yes. Passes VLT and HLT, the vertical line test and the horizontal line test. All right, let's talk about this beast here. This is a little bit different. You'll notice the only difference between these two is this negative right here. Let's see. What would happen if I put in a 5 there? So I say, or not a 5, a 1. 2 square roots of negative 1. Huh? You don't know what the square root of negative 1 is. Not until later in this unit. But right now, you don't even know what the square root of negative 1 is. So I can't put in 1. Can I put in 4? So 2 times the square root of negative, and I'm putting in a 4. 4. Remember, putting it in for x. So that's not going to work. Okay. So you can't put in positive values. But I can put in negative values. Oh, I can put in 0. 2 times the square root of negative 0. That's still 0. But what about 2 square roots of negative? And now I'm going to sub in negative 1. Well, negative makes a positive. This is really 2 square roots of 1, which is just 2. Oh. So if I plug in negative 1, I get 1 out. Well, and I get 2 out in this case because I got a multiplier. If I plug in negative 4, 1, 2, 3, 4. So if I plug in a negative 4 there, that's negative 4, which is 2. So that's going to be up here, and this will be here. So plugging in negative in, this negative right here on the inside of this radical is a reflection over the y-axis. All right, let's talk about domain. Domain. What is the smallest x value? Well, the biggest x value is right here. The smallest x value is way over here. So if I'm talking about domain, it's from negative infinity to 0 bracket. What about range? Well, the lowest y value is still 0, so that goes on the left. And it goes forever and ever and ever up. I don't care that it's going left, it's still going up. And since it's going up, it's going to positive infinity. Is this a function? Yes, it passes the VLT. Passes VLT. Is it a one-to-one function? Yes. It passes VLT and HLT. By the way, if it wasn't a function, you're done. You can't even say it's, even though it passes the horizontal line test, it's still not a function. It's still not a one-to-one function. All right, so let's graph this thing. Holy mackerel. What are we going to do with this? Well, let's plug in 0. 0 gives me 0. That's not a problem. Let's plug in 1. The cube root of 1 is 1. Anybody know off the top of their head what the cube root of 2 is? Or to 3, or 4, or 5, or 6, or 7, or 8, or 9, or 10? One of those is a perfect cube. So 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27, but that would be off our graph. So if I put an 8 in here, the cube root of 8 is 2. So you might think, oh, there we go. There's our graph. And the next one would be up at 27. That would be 3. There's our graph right there. Let's take a look. Let's see what we got here. So we'll just doc B this. And we'll go into graph mode. And we'll type in, let's see, to get the cube root, you got to go dink, dink. And we plug in a 3. And then we plug in an X. And then we go, enter. Whoa, 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 whoa. Let's back up the crazy train there. What happened? I can go, wait. Oh, this isn't a square root. It's a cube root. Oh. So a cube root can go to the left and to the right. The square root can't. Now, here's why. Here's why. You can, make sure you understand this. I don't know where I'm going to put this. Put this in a note somewhere. Let's see if I can put it over here. You can. You can take the square root, take the cube root of a negative number. For example, what's the cube root of negative 1? Negative 1 times negative 1 times negative 1. Oh, that's negative 1. What's the cube root of negative 8? Negative 2 times negative 2 times negative 2 is negative 8. Oh, that's negative 2. So I can take the cube root of negatives. Okay, so if I plug in negative 1 for x, the cube root of negative 1 is negative 1. Now the next one's going to be 8 again. So the cube root of negative 8. If I took the cube root of negative 8, I would find out that that's equal to negative 2. So here is your next toolkit function. Here's your next toolkit function right here. The cube root of x. You need to know it's this squiggly looking thing like this. And if you looked at it graphically, that's what it's going to look like. That cube root of x. That's what it looks like. You need to memorize it. All right, so what happens when we put a negative in front? We've already talked about this. Putting a negative in front is a reflection over the x-axis. Remember, now this also has a 3 out front, which is just going to make it steeper. But remember, this is the cube root function normally. There's your cube root function normally. So if I reflect this over the x-axis, I end up down here. If I reflect this over the x-axis, I end up here. So that negative makes it makes it a reflection over the line, over the x-axis. Now the 3 just makes it steeper. The 3 just makes it steeper because I plugged in negative 3, the cube root of negative 1. Well, the cube root of negative 1 is negative 3 times, times negative 3 is, negative 3 times negative 1 is positive 3, and that's why it's up here. Now, the cube root of negative 8 is negative 2, but when I multiply that times negative 3, I end up here. And that's why it's steeper. Oh, we didn't do domain and range. Let's go back and do domain and range. The domain is quite simple. It's going for the left and right forever and ever and ever. So domain is all reals, or negative infinity to positive infinity. By the way, you could say x is in the set of all reals. That's another way to represent that x is in the set of all numbers, all real numbers. Range. Range. Well, you may not see it. Maybe I can help you with it. If we just extended this going on forever and ever and ever, come on. What happened? That's for later. And we go off forever and ever and ever and ever. And we keep going. And it goes off forever and ever and ever and ever and ever. All reals. It will go forever and ever to the left or up, and it will go forever and ever down. It's going forever and ever up, and it's going forever and ever down. It's just doing it kind of slow. Is it a function? Is it a function? Let's see if I can get rid of that blue. Let's see if I can get rid of that orange. Okay. Is it a function? Well, of course, yeah. Yeah, of course. It passes the vertical line test over and over and over again. So, yes, it's a function. Yes. Passes VLT. Is it a one-to-one function? Well, yep, it is. Yep, passes the one-to-one function because it passes the VLT and the HLT. Yes. I just wrote yes. Yes. Passes VLT and HLT. All right. Let's go over here. Domain and range. Well, it's still going forever and ever to the left, and it's still going forever and ever to the right. Still going forever and ever down. It's still going forever and ever up. So domain and range is all reals. Again, you could, by the way, you could also write this as y is in the set of all reals, and x is in the set of all reals, if you like. Oops. I make these fancy R's. Lots of math teachers do that. Is it a function? Yes, it passes the VLT. Is it a one-to-one function? Yes, it passes the HLT. Now, some of you might say, wait a second, whoa, let's back up the crazy train. That doesn't pass the vertical line. Look, I draw a vertical line and I'm hitting it. It's right there. I'm hitting it like right there and right there and right there. Okay, let me try to explain this one to you. Menu, let's go tab, go up, tab, doc B. Okay, so the -3 cube roots of x. And you're right, look at it. It looks like it doesn't pass. But watch this. Menu, zoom. Damn. Let me do it with my mouse. Menu, zoom in. Do you see how it may look like it's up and down, but look, as we get closer and closer, you'll notice it's just a little bit off. Let's see if I can do this. Oh, that's not really helping. This way is helping. Notice zoom. If I really zoom in there, and I'm trying my hardest to zoom in as much as possible, it really doesn't touch the x-axis until it gets right here at the origin. Other than that, it gets really close, then touches it, and it's really close and goes the other way. So although it looks like it might fail the vertical line test, it does not. Okay, that's those. Let's review. The A is a dilation. I just spelled that right. No, I spelled it dilation. So the A is a dilation. It's either going to get steeper or shallower. I should have had a negative out front. I don't know why I don't. Why is there not a negative out front? This negative would reflect it over the x-axis. So if I put a negative out front, that would reflect it over the negative of the x-axis. This negative reflects it over y-axis. This, or this, it doesn't matter, is a horizontal that's left or right, shift backwards. And what I want you to remember is if I'm adding, I go to the left, and if I'm subtracting, I go to the right, backwards. And these two, this K and this K, these are vertical shifts. That's up or down, but normal. So you should, without the use of a calculator, be able to tell me all that's going on this. We know we have a dilation. This is kind of tricky. I started with a very tricky one, didn't I? You have this minus 3 in here, and normally we'd say, oh, minus 3, we go to the right 3. However, it is a reflection in the y-axis, so we're actually going to go to the left 3. And if you want to think about it like this, it's really negative x plus 3. And that negative says we're going to reflect it, and then the plus 3 says we go to the left. So normally, if that negative wasn't there, I would put my point here, and we'd be drawn off that direction. But because that negative's there, it's a reflection over the x-axis. And I should have put it, instead of here, I'm going to put it here. Now, plus 2, that means we're going to go up 2. Normally I would go up here, but because we're reflecting over the x-axis, that's why I put that point there. And normally we'd go to the right, but because of that negative, that's a reflection over the y-axis, we're actually going to go to the left. So we're going to go off in this direction. Don't draw that. That's silly. Okay? Normally we go to the left 1 and up 1, but because we have this dilation of 2, we're going to go to the left 1 and up 2. Normally we would go to the left 4, 1, 2, 3, 4, and up 2. But because of the dilation 2, we're going to go up 2. So this is what this looks like. Now again, you can use a calculator to verify this, but that's it. Domain starts at negative 3, goes to negative infinity. Negative infinity is the small number, it goes on the left. Negative 3 is the big number, it goes on the right. For range, we're going to start here at 2, and we're going forever and ever up, bracket 2, comma, positive infinity. All right, moving on. So this is a cube root. Now you need to know what the parent function of a cube root looks like. It's going to look like this. A little wiggly. That's generally what it's going to look like. It's got a dilation, and it also has a movement to the right 4. 1, 2, 3, 4. And that's where we're going to put our point because we have no other point. So right 4. So now it should look like this. But that's not good enough. That's not good enough for this course. That's good enough for some sloppy course. That's not good enough for this course. So normally I would go to the right 1 and up 1 because the cube root of 1 is 1. But because of this 2 again, I got to go to the right 1 and up 2. Now the next perfect cube is 8. So normally I'd go 8, 1, 2, 3, 4, 5, 6, 7, 8. And normally I would go up 2, but now I got to go up 4. Now that's not even on the graph, so you really shouldn't even be graphing it, but that gives me a general idea where I'm going to be pointing towards. Looks like that. All right, so let's go in the other direction now. Left 1, down 2. Left 8, 1, 2, 3, 4, 5, 6, 7, 8. All right, we want left 8, and we're going to go not down 2, but down, because of the multiplier, down 4. And the next one would actually be over at 27. There you go, just like that. That's what she looks like. Okay, I knew this was going to be a long video. We still got 3 pages left. Wait, don't tell me if we got 4 pages left. 3 pages left. I guess see. Oh, I can't remember. 3. All right. A rock average rate of change. Now remember, the average rate of change is really slope, but you got to do it a little bit differently. The average rate of change is really the change in y over the change in x. Or in other words, it's f of x2 minus f of x1 all over x2 minus x1. It's no longer good enough to use y2 minus y1 over x. This is the formula you really should be using, this functional notation. It makes you seem more grown up, and it makes you get ready, and it's getting you ready for pre-calc, okay? So that's the functional notation we should be using for the average rate of change. Now, if you remember from Unit 1, the average rate of change for a line is just the slope. But that's not going to be true for these. Take a look at these things. Where's the average rate of change? You know, I got to take a look at the slope, you know, average rate of change of these points. It's not the instantaneous rate of change that you'll be doing in calculus. The average rate of change. The instantaneous rate of change, by the way, is the first derivative evaluated at that point, but you don't want to do that. You don't want to. You're not ready for that. You're not ready. You'll do that probably next year, but you're not ready for that this year. So we're just going to find the average rate of change over this interval. We've got a square root function, and we're going to find the average rate of change. So the average rate of change, the AROC, is going to be equal to f of 7 minus f of 3 all over 7 minus 3. 7 minus 3, by the way, is 4. So 7 minus 3. I'll do the denominator for you. That's pretty easy. It's 4. Okay, I'll do the top for you too. F of 7 is equal to the square root of 7 minus 3 plus 4, which is equal to the square root of 4 plus 4, which is equal to 6. The f of 3 is equal to the square root of 3 minus 3 plus 4. That should be pretty obvious. That's 4. So my average rate of change is 2 over 4, which of course is just 1/2. There's the average rate of change. That's it. Same as last unit. It's just a little bit more complicated. Okay, we're going to do average rate of change for these. So some of these are pretty easy. The average rate of change here. So for -4 to -2, that's just a line. And the average, and that slope, the AROC there, is just 0. This last one, 2 comma 4, that's just a straight line. So its average rate of change is the slope, which is down 1 over 1. So that's -1. It's coming down. This is the one that's a little bit tricky. The average rate of change from -2 to 2. So remember, this is going to be the f of 2 minus f of -2 all over 2 minus -2. Well, 2 minus -2 is 4. And let's see, what is the y value here? The y value here is -2. My watch is telling me I'm being lazy. It doesn't realize I'm working. And what's the y value here? Oh, the y value here is 0. So this ends up being 0 minus -2, which is just 2 over 4. So it's 1/2. So the question says, over which interval is the average rate of change the greatest? The answer then would be over this interval. Remember, average rate of change, when we're talking about greatest, doesn't matter if it's negative or positive. Which one has the greatest change? That has the greatest change negatively, but it doesn't matter. All right, so that one's done. Determine the average rate of change from -2 to -1. All right, so let's do this. So all we're going to do is we're going to do the AROC, average rate of change. So that's f of -1 minus f of -2 all over -1 minus -2. Notice I'm using parentheses, especially with negatives. You run into all kinds of problems when you don't do things in with parentheses with negatives. So this really becomes -1 plus 2, which is really just 1. So let's see what the numerator is. What is f of -1? What is the y value there? The y value there is 3. What is, 3. What is the y value at f of -2? Oh, the y value there is 2. So this is just 3 minus 2, which is 1 over 1. So the answer is just 1. Oh man, I'm probably right by my big head. 1. The answer is 1. All right, kids, 2 pages left. Analyzing some graphs. Let's do some analyzing of graphs and we'll be finished. Okay, so let's see what we got here. Is this a function? It should be obvious, yes. And if you're asked to explain why, you'd say passes VLT. Is it a one-to-one function? Yes. It passes VLT and HLT. Domain. Okay, the lowest x value is right here at -2, and it's going forever and ever to the right. So bracket -2 to the right. The lowest y value is down here at -8, and it's going forever and ever up. Now, increasing and decreasing. Remember, as we're talking about these, again, I got to remind you, we're talking about using the x values. And increasing is, where is it going up? Well, if I start here and I go to the right, I'm always going up. So starting at -2, you can't use -2 because at -2 it's an endpoint. You shouldn't use it. So -2 to infinity. Where's the graph decreasing? It is not empty set. You can either use that or this is also the empty set. I just like the curly brackets with nothing in them. It really drives home the point that it's empty. What is the minimum value of the graph? Now, minimum and maximum, when we're talking about minimum and maximum, we're talking about y values. Minimum and maximum are going to be the y values. So the minimum is the minimum y value is -8. So y equals -8. The maximum y value is y equals infinity. So you really can't ever equal infinity. So the maximum value is infinity. What transformations occurred on the parent function? Okay. Clearly it moved left 2. Clearly it moved down 8. It also has a dilation, because don't forget, we're supposed to be able to go to the right 1 and up 1. We went to the right 1 and up 2, so it's got a dilation of 2. Now, if I had to write this function, it would be f of x equals 2, this is a square root function, x plus 2, because it moved left 2, down 8. And that would be the function. All right, moving on. Last problem. All right, there's a cube root function. So what is the domain? Domain, all reals. Goes forever and ever to the left. It goes forever and ever to the right. What's the range? It goes forever and ever down. It goes forever and ever up. X-intercept, oh, okay, 0, 5. Y-intercept, 5, 0. Where is this graph decreasing? Or is this graph decreasing or increasing? Well, if you watch this, remember, we got to read from the left to the right. As I go from the left to the right, what's it doing? It's going up, it's going up, it's going up, it's going up steep, real here steep, and then going up, it's going up and up. So it's always increasing. Remember, always reading from the left to the right. Where is y less than 0? This means where is y negative? Where is y going to be negative? And if you remember from the last unit, negative means below the x-axis. So here, in going in this direction, we are below the x-axis. So from negative infinity all the way up to -5, you can't include -5 because that's where it's equal to 0. It's less than 0. Where is it equal to 0? At y equals -5. Where is it? Positive. Remember, this doesn't mean greater than 0. It means positive. And it's positive starting at 5 and going in this direction. So from parenthesis 5, comma, infinity. Is it a one-to-one function? Yes, it is. Passes VLT and HLT. By the way, if I had to write this function, clearly this is a cube root function, so we're going to write f of x equals. Now I'll just put a cube root in there. All right, so we move to the left 5, x plus 5. There was no reflection in the x-axis, so I don't have to worry about a negative out front. But it does have a number out front, because normally I would go over to the right one and up one. In this case, I went over to the right one and up 3. So my number in front is a 3. And that's it. That would be the equation for this function. All right, that's it. That's all she wrote. Day 1 is over. Thank you for joining me. Hit the subscribe button, hit the like button, and leave us a comment if you want. I know. I need to shave and I need to cut my hair. Maybe in the next video. Bye, kids. Catch you on the flip side.